Hello, my dear students. Today we are going to continue chapter 1, which is transition metals. We are going to discuss the properties of iron, physical and chemical properties. Then we are going to discuss the types of iron oxides and their preparation and their chemical reaction. So let us start. Properties of iron. First, we are going to discuss the physical properties of iron. The pure iron has ferromagnetic property, which means strongly attracted to magnet. The pure iron has no industrial use, or we can say, not preferable to use iron in pure state. And so we have good reason for this point. The answer, because it is relatively soft, which means low hardness, malleable and ductile. Next point, the physical properties of iron depend on the purity of the iron and the nature of its impurities. The alloys of iron and steel have different properties and uses. The iron melts at 1538 degrees Celsius and has density 7.86 gram per cubic centimeter. The chemical properties of iron. The iron doesn't show the maximum oxidation state corresponding to removal of all its valence electrons from the 3D and 4s sublevels. So we have two oxidation states in the iron reactions, the positive 2 oxidation state, which is corresponding to losing 4s electrons only, and the positive 3 oxidation state corresponding to stable configuration, which is 4s0, means no electrons in the 4s sublevel, and 3d5 electrons. Now we are going to discuss the chemical reactions of iron. My dear students, now we are going to discuss the chemical reactions of iron. We are going to discuss the effect of air and water vapor on iron, and we are going to make the reactions of iron with nonmetals like chlorine and sulfur, and then we are going to discuss the reaction of iron with the acids. So let us start. The chemical reactions of iron. The effect of dry air. The red hot iron reacts with dry air or oxygen, giving magnetic iron oxide. As the equation proceeds on the screen, 3Fe plus 2O2 by heating gives Fe3O4, which is magnetic iron oxide, which is black iron oxide, as the following animation show. As the shown on the screen, when burning iron and we make its burns in oxygen, it forms the black iron oxide Fe3O4 that we call magnetic iron oxide. The effect of water on iron. The red hot iron above 500 degrees Celsius reacts with water vapor or steam, giving magnetic iron oxide, which is black iron oxide, and hydrogen gas is produced. As the equation proceeds on the screen, 3Fe plus 4H2O, 500 degrees Celsius, it gives Fe3O4 and 4H2. That means that hydrogen gas is produced. Now the reaction of iron with non-metals. The iron reacts with chlorine to form iron 3 chloride. As the equation proceeds on the screen, iron plus chlorine by heating gives iron 3 chloride or ferric chloride, which is red-brown color, as the following animation shows. As shown on the screen, when heating the iron and putting it in chlorine gas, we find the reaction proceed and producing iron 3 chloride, which has red-brown color as shown on the screen. As the equation shown on the screen, iron plus chlorine gives iron 3 chloride. Now we are going to discuss the reaction of iron with sulfur, which is another non-metal. It forms iron 2 sulfide. As the reaction proceeds on the screen, iron plus sulfur by heating gives iron 2 sulfide or ferrous sulfide, which has gray color as the following animation shows. As shown on the screen, on heating iron and putting it in the sulfur, the reaction proceeds between the iron and sulfur, and it gives iron 2 sulfide, which has black color, as shown on the screen. Dear students, we have give reason in this point. The iron reacts with chlorine, giving iron 3 chloride, not iron 2 chloride, while it reacts with sulfur, forming iron 2 sulfide. The reason for that, when chlorine gas is reacting with the iron, the chlorine is a stronger oxidizing agent, and so it forms iron 3 chloride than sulfur that gives iron 2 sulfide, which refer to the high electron affinity of chlorine than sulfur that make oxidation of iron 2 into iron 3, while with iron doesn't make oxidation of iron 2, so it remains iron 2 sulfide. The reaction of iron with acid. When iron reacts with dilute mineral acids, it forms iron 2 salt and hydrogen gas. As the equation proceeds on the screen, iron plus HCl, it gives by dilute HCl, it gives iron 2 chloride and producing hydrogen gas, as the following animation shows. When putting iron nails in test tube that containing dilute hydrochloric acid, we see bubbles of hydrogen is produced and forming iron 2 chloride, and so the reaction proceeds, giving hydrogen gas and iron 2 chloride as shown on the screen. When the reaction of iron with sulfuric acid, that is dilute acid, it gives also iron 2 salt, iron 2 sulfate, and releasing hydrogen gas. And as the reaction proceeds on the screen, we form iron 2 sulfate as the following animation shows. As shown on the screen, we bring piece of iron and put it in dilute sulfuric acid. We observe that bubbles of hydrogen gas is produced and the iron changes into iron 2 sulfate. So we have give reason in this point. Iron reacts with dilute hydrochloric acid or dilute sulfuric acid, forming iron 2 salt, not iron 3 salt. The reason for that is the produced hydrogen gas is reducing agent that prevents the formation of iron 3 salts. Now, my dear students, we are going to discuss the reaction of iron with concentrated sulfuric acid that gives iron 2 salt and iron 3 salt and sulfur dioxide gas and water, as the following animation show. As shown on the screen, we bring here sulfuric acid concentrated, and we are going to put in it iron bits, and we show the reaction that happens in that beaker. We find that the reaction gives iron 2 sulfate, and iron 2 sulfate is oxidized into iron 3 sulfate by the action of the concentrated sulfuric acid as it is oxidizing agent and forming iron 3 sulfate and releasing sulfur dioxide gas that has irritating smell and producing water. Here the reaction as shown on the screen, some water is present as is not concentrated 100%. My dear student, the reaction equation proceed on the screen. Iron plus sulfuric acid, which is concentrated and heated, it gives iron 2 sulfate and iron 3 sulfate and sulfur dioxide gas and water is produced. So we have good reason in this point. Iron reacts with concentrated sulfuric acid forming both iron 2 salt and iron 3 salts. The reason for that is sulfuric acid is a strong oxidizing agent, giving both iron 2 sulfate and iron 3 sulfate. As the equation proceeds on the screen, the iron 2 sulfate is formed and iron 3 sulfate and sulfur dioxide gas and water is produced. And the give reason for this point, iron does not react with concentrated nitric acid. The reason for that is due to their passivity, which means a protective non-porous layer of metal oxide is formed on the surface of the metal of the iron, which is larger in size than the metal molecules, than the iron molecules, that prevent the iron from further reaction. So it is considered chemical inactivity or passivity. My dear student, notice that the metal oxide layer is removed by using dilute hydrochloric acid. Also, my dear student, remember that iron 2 salts are reducing agent as easily oxidized, while iron 3 salts are oxidizing agent as easily reduced. Here we have a very important point, how to differentiate between iron 2 chloride and iron 3 chloride. Here we put the salt solution plus sodium hydroxide solution. The observation here, if white-green precipitate is formed, it will be iron 2 chloride. As the equation proceeds in the screen, sodium hydroxide plus iron 2 chloride, it gives iron 2 hydroxide, white-green precipitate, and sodium chloride is produced, as the following animation. Here, my dear student, when putting iron 2 chloride with sodium hydroxide, the reaction proceeds giving iron 2 hydroxide, which is white-green precipitate as shown on the screen, that indicating that the salt of chloride is iron 2. But if we put the salt solution of the salt, that is iron 2 or iron 3, plus sodium hydroxide solution, and giving reddish brown precipitate. The salt is iron 3 chloride. As the equation proceeds on the screen, sodium hydroxide plus iron 3 chloride, it gives reddish brown precipitate and sodium chloride, as the following animation shows. As shown on the screen, we put sodium hydroxide over iron 3 chloride. It gives reddish brown precipitate of iron 3 hydroxide. Here, my dear student, we can differentiate between the iron 2 salts and iron 3 salts by adding sodium hydroxide. The hydroxide formed here determine which salt is present. Is it iron 2 or iron 3? If white-green precipitate is formed, it will be iron 2 salt. If reddish-brown precipitate, which is iron 3 hydroxide, so it will be iron 3 salt. Now we are going to discuss the iron oxides. The first oxide we are going to discuss is iron 2 oxide, FeO. The preparation of iron 2 oxide from heating iron 2 oxalate in the absence of air, as the equation proceeds on the screen, it gives iron 2 oxide and the carbon monoxide gas and the carbon dioxide gas. And so we have give reason in this point. Heating iron 2 oxalate gives iron 2 oxide, not iron 3 oxide. The reason for that is the produced carbon monoxide gas is a reducing agent that prevents the formation of iron 3 oxide. The second point for preparation of iron 2 oxide is the reduction using reducing agent as hydrogen gas or carbon monoxide gas. So, if we reduce iron 3 oxide Fe2O3 by hydrogen gas at temperature 400 degrees Celsius till 700 degrees Celsius, it gives iron 2 oxide and releasing water vapor. But when using magnetic iron oxide Fe3O4 and reduced by hydrogen gas, also from 400 till 700 degrees Celsius, it gives iron 2 oxide releasing water vapor. My dear student, you can use hydrogen or carbon monoxide for these reduction processes. Now we are going to discuss the properties of iron 2 oxide. It is black, solid, insoluble in water. It reacts with dilute acids to give iron 2 salt. As the reaction proceeds now, when the iron 2 oxide reacts with dilute hydrochloric acid, as the equation shown on the screen, iron 2 oxide plus hydrochloric acid, which is dilute, it gives iron 2 chloride and water, which is iron 2 salt, is formed by adding the iron 2 oxide to any dilute acid. So, if we make the reaction between the dilute sulfuric acid and iron 2 oxide, it also gives iron 2 salt, which is iron 2 sulfate and releasing also water. Now we are going to discuss the oxidation of iron 2 oxide. When heating iron 2 oxide in air, it gives iron 3 oxide. Now we are going to discuss the reduction of iron 2 oxide. When reacting iron 2 oxide with reducing agent as carbon monoxide or hydrogen gas above 700 degrees Celsius, it gives iron releasing carbon dioxide gas. Or we can use hydrogen for the reduction as shown on the screen, FeO plus H2 also above 700 degrees Celsius, it gives iron releasing water vapor. Now we are going to discuss the second type of oxides, which is iron 3 oxide, Fe2O3. The preparation of iron 3 oxide by heating iron 2 sulfate. As the equation proceeds on the screen, on heating iron 2 sulfate, FeSO4, it gives iron 3 oxide and sulfur dioxide gas and sulfur trioxide gas. So we have good reason in this point, my dear students. Heating iron 2 sulfate gives iron 3 oxide, not iron 2 oxide. The reason for that, because the produced sulfur trioxide gas is oxidizing agent that prevents the formation of iron 2 oxide. Now we are going to discuss the second way for preparation of iron 3 oxide, which is done by heating iron 3 hydroxide. As the equation proceeds on the screen, on heating iron 3 hydroxide that has reddish brown color above 200 degrees Celsius, it gives iron 3 oxide and water vapor. My dear student, notice that when iron 3 chloride reacts with sodium hydroxide or ammonium hydroxide, it gives reddish brown precipitate of iron 3 hydroxide as shown on the following animation. When adding sodium hydroxide to iron 3 chloride, it gives iron 3 hydroxide that on heating it can give iron 3 oxide that we want to prepare. As the equation proceeds on the screen, if the reaction done with sodium hydroxide, iron 3 chloride plus sodium hydroxide, it gives iron 3 hydroxide and sodium chloride is produced. Or the reaction with ammonium hydroxide or ammonia solution, iron 3 chloride reacts with ammonium hydroxide, giving iron 3 hydroxide, releasing ammonium chloride. Now we are going to discuss the properties of iron 3 oxide. It occurs as hematite and it is insoluble in water. It is used in red pigments in paints and reacts with hot concentrated acid to give iron 3 salts. So, my dear students, we can differentiate between iron 2 salts and iron 3 salts, and also we can differentiate between the iron 2 oxide and iron 3 oxide by the reaction of the iron oxide with acids. Here the reaction of iron 2 oxide and iron 3 oxide with dilute acids, only iron 2 oxide dissolve and react, while iron 3 oxide doesn't react, as it reacts only with hot conc acids. As the reaction here on the screen, the reaction with hot conc hydrochloric acid with iron 3 oxide, it gives here iron 3 chloride and water is produced. Also reacts with hot concentrated sulfuric acid. Here iron 3 oxide reacts with sulfuric acid by heating and concentrated. Here it gives iron 3 sulfate and water is produced. So my dear students, iron 2 oxide reacts with dilute acids, while iron 3 oxide reacts also but with concentrated acids, and this is done by heating as shown on the screen. The reduction of iron 3 oxide. Here where iron 3 oxide reacts with carbon monoxide from 230 till 300 degrees Celsius, it gives magnetic iron oxide and releasing carbon dioxide gas. Here the reduction takes place from 230 till 300. But when the reduction takes place from 400 degree till 700 degrees Celsius, the product is be different. Here it gives iron 2 oxide and water vapor. So the reduction of iron 3 oxide depends on the temperature. When 230 till 300, it gives magnetic iron oxide, but from 400 degree till 700 degrees Celsius, it gives iron 2 oxide as shown on the screen. If we make the reduction of iron 2 oxide, here above 700, it gives iron and carbon dioxide gas. My dear students, we have finished our program today. I hope you understood all the points that we discussed today and the chemical reactions that we discussed today. So, till we meet again, my best wishes for you.